Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's my great pleasure today to introduce Roger Danberg from CMU. Most of you here probably already know that he's a very big figure in computer music, and what you may not know is that he's worked in a huge variety of aspects of computer music throughout his time there. So, well, before I even get to that, I mean, he's an associate professor at CMU in computer science, and also has an appointment in the art department. He has worked not only in, so let's start with the programming language stuff. So first, he worked on programming languages for music and for sound synthesis, brought some of the first functional programming language ideas into sound synthesis, stuff which is still used today. He's worked on automatic teaching systems for music, like the piano tutor system, I believe it was called, which would take a year's worth of music instruction and compress it into something like 20 minutes of time.
20 hours.
20 hours, okay. 20 minutes would be great, but 20 hours is still pretty good. Which was very revolutionary. And more recently, he's done a lot of work on music analysis, looking at structure analysis, as well as trying to recognize genres and styles of music. In addition to all of that, and being a professor at CMU, he's also managed to be a world-class performer. He plays the trumpet, and he's played with a lot of amazing people. He's performed the Apollo Theater in Harlem and all kinds of other places. It's just an amazing guy, and I'm really, really happy to have him here for the day and get this job. So, anyway.
All right. Oh, thanks very much. It's great to be here. So what I'd like to talk about today is work, a little bit about work that I've done in music understanding, and really try to focus today on an application area that I'm moving into. And so I think the main point of this is that I think music is for everyone. Millions of people are practicing musicians, so I'm not talking about just listening to music, but actually performing music. And this is something that just a startling number of people do at some level of proficiency, and many, many more people would like to do that. And so I think that computing is a way to make music performance more fun, more available, higher quality, and it's a big area to explore, and I spend a lot of my time doing that and thinking about that. So what are the problems that we can solve in this area? Well, one thing, and a very big thing, is just practicing is a lonely thing for most people. You don't really want to practice with other people. The funny line that when a musician makes a mistake, the guy next to him, if he wants to make a joke, says, "Hey, practice at home." And so, but also musical partners are not always available. So if you want to play music in an ensemble and you're not doing that daily on a professional basis, it can be hard to get people together and make sure all the parts get covered. Another issue for amateurs is that while 100 years ago all music was live and the quality of music was not necessarily all that great by today's standards, now we have recordings of the best symphonies, the best solos. We almost don't hear anything but a virtuoso playing. And so if you're an amateur, you've got a much higher bar setting the standard for music. And so we might think about ways that we can help amateurs achieve the quality of sound that they imagine and that they would like to do. So, what if we had computers that could play with us, editors that could fix our mistakes, and new forms of personal expression? And so this is the direction I want to go. And I think an important way to get there is this research that I call music understanding, which is the recognition of pattern and structure in music. So that's intentionally a very broad kind of definition, all-encompassing almost. And so what do we mean by pattern and structure? Well, I really mean structure at many different levels. So we have what we might call surface structure in music, which are things like pitch and harmony, loudness, identifying notes. All right, so these are very, very specific, not very abstract concepts. And then there's much deeper structure in music, such as the relationship between phrases, the association between printed music and music audio, emotion in music, both understanding what music is trying to express, and also understanding how to express an emotion through a musical performance. And that's just part of expressive performance, which includes not only emotion but other kinds of musical issues. And so trying to get computers to deal with all of these aspects of music is my biggest interest and really the main goal of music understanding. So there are some tasks in music understanding. This is not all of them, but just generally, I would say in music understanding, we work on problems related to matching musical sequences. And so by a music sequence, I mean both music notation or something like a MIDI file, symbolic and performance information, and also audio information. So we have problems of matching symbolic scores to audio. We have problems of matching audio to audio. For example, find covers of given a song, find other artists who have recorded the same song but in a different style. So those are some different kinds of music sequence matching problems. And also searching for music. So query by humming systems where you hum a tune and look for it in a database. That's another music sequence problem, music recognition problem. Okay, so another set of problems have to do with parsing music. And that includes classification, understanding either genre or emotion, or identifying instruments. It includes segmentation and structure. So, for example, find where the beats are, find where the notes are, find find the chorus of a pop song that gets repeated several times. So, find that section of music that tends to repeat. And so those are all. I mean, I put the word parsing in quotes, but generally, there's a whole set of problems associated with that type of thing. And then finally, there's expressive performance, which I mentioned before. And expressive performance really has to do with the gap between taking a piece of music notation, where everything, at least in Western notation, things are quantized to beats, and absolute rock steady metronome tempo. And you feed this into a synthesizer, and you get something that sounds like an early cell phone performance, and it's not very musical or very interesting. And so there's this big gap between between that just literal rendering of note information and what a human musical performer can do to make the music expressive. So I'd like to start by showing this video, and probably at least a couple of you have seen this, and I apologize for showing it over and over again. But this is some of the first work that I did in the field, and I think it's still such a good example of what can be done that even though I could show you more modern versions, I think it's more impressive to see here's stuff that actually ran in 1985, and it was kind of an applied music understanding system. So let's switch to, whoops. Okay, here we go. This is a demonstration of a computer accompaniment system. I'm going to begin by loading a file into the program. The file contains a score, and in the score there's a part that I'm going to play on trumpet. That's also displayed on the screen. There's another part, which is an accompaniment part, in this case composed quite some time ago. The purpose of the program then is to listen to my performance, a live performance of the solo part, and to synchronize the other parts and play them along with me. The computer accompaniment system is based on a very robust pattern matcher that compares the notes of the live performance as I play them to the notes that are stored in the score. To illustrate how well the pattern matching works, I'm going to deliberately create a nightmare for the accompanist by playing lots of wrong notes, changing the tempo, and missing some notes. Okay. Okay. So just a quick word about how that works and what's going on. There's a the trumpet performance is going into a this input processing box, which really is doing pitch recognition, and the computer, because I've loaded up this score, has a sequence of what I'm supposed to be playing, and those get matched together using a kind of a modification of the longest common subsequence string matching dynamic programming algorithm, modified to deliver results incrementally in real time. And then the accompaniment part is also stored with the score. And I think the most interesting thing about this structure is that this matching process and the accompaniment performance process are loosely coupled processes. So the information from matching is constantly going over into the accompaniment performer, but the performer doesn't play exactly what is matched because it's trying to do a musical performance, and it knows, or the system is based on the fact that an accompanist is another musician. So that accompanist has an idea of what the tempo is and how to perform things musically, and so these are kind of loosely coupled performances, and of course the output from that just drives a music synthesizer, and so that's what you're hearing. Okay, so this work is based on, or that video and that whole accompaniment system is based on the idea that music is played with expressive timing, and the way that you should accompany a performer is to listen carefully to the notes that they play and listen carefully to their timing and adjust to comply, to synchronize with that. So if you speed up a phrase and slow down a phrase, then the accompaniment is going to follow that. And that is a bit of a simplification, but it's more or less the way we make Western classical chamber music. And so this system is good for that. And lots of people, this has been commercialized. There's over 100,000 students using practice systems, able to practice at home, doing this kind of music. And that's all great. But long after doing this, I was playing with a rock band, and just getting a little bit frustrated that I couldn't. There were some notes that I was just, at the end of the night I'd be really tired and they were hard to hit, and the band played so loud that it was hard for me to come up to that volume. And I was just thinking about, every once in a while it'd be really great if I just had some samples of my playing when I'm feeling really good, and and if I could just cue them and get them into the sound system. The band is so loud, nobody would know that it's not coming acoustically out of my trumpet. We could just come out of the speakers, and that would be really great. And then if you could do that, then I'd say, why stop there? Instead of 2 trumpets and a trombone and a sax, we could have 3 trumpets and 2 trombones and a couple of saxes. Yeah, well, except that we'd be in control and we'd be performing. But it's close to nilly vanilly, and so my second thought was, hey, wait a minute, I've already done this. I know how to build accompaniment systems. This is just an accompaniment problem. And I thought, yeah, I should do that. And then so the third thought that I had was, wait a minute, if I really want to play effectively with a rock band, the really important thing is timing, and also to do the kind of music that we're playing, the trumpet, the accompaniment system can't really follow another trumpet player, because we sit out for 16 measures or more, and then suddenly we just come in on this entrance. And the entrances are, well, the whole band doesn't necessarily follow a strict score from beginning to end, because there might be some improvisation, there might be mistakes you have to deal with. And also, even following, if you didn't want to follow a trumpet, maybe you want to follow a guitar player or something, but the guitar player is playing off of chords. He's not playing individual notes that we can actually recognize. He's not doing that consistently from one performance to the next. He might just say, okay, I'll voice this chord differently, or I'll use a different strumming pattern tonight, and who knows what could happen. And so the more I thought about it, the more I realized this is a completely different problem. And but it's a big problem. I mean, it's big in the sense of lots of sub-problems, lots of twists, and also lots and lots of applications. So I call this problem performing popular music with computers. And I don't really like the word popular, but I use popular because that seems to be the best word that characterizes a very wide class of music where tempo is very steady. So I really could call it performing steady tempo music with computers, but somehow that seems a little awkward. But I mean not the pop genre, but I mean rock. Could be rock, pop, techno, jazz. Well, most jazz is in this category. Most folk music is in this category. So it's actually very, very wide class of music. So the goal is to create more musical opportunities for people, to create ultimately new artistic directions for musicians. And when I say performing popular music, the performing part implies that we're going to do live. This is for live performance with humans and computers. And the popular part, I explained, means steady beat. So the big research question is, how can we coordinate human and computer performers of popular music? And have an example to show you, another video. So this is work, this was sort of the first implementation of a system that we took out for a test drive in April of this year with the Carnegie Mellon Jazz Ensemble. And we set this up as a initial problem without even implementing the system. The first thing I did is I went to a really wonderful arranger, John Wilson, who's the guy conducting here, and asked him if he would write a big piece for a jazz ensemble and a 20-piece string orchestra. Or the 20, he actually gave me the number 20, but I said, how many strings do you need to do something that would just sound great? And he said, well, give me 20. And I said, okay, 20, not really knowing how I was going to do this, that's what we decided. So he went off and did arranging, and I went off and started writing software. And we talked a lot about how we were going to synchronize and what he could and could not do in the arrangement. But this is what we came up with. Oops. Okay, I'm going to pause for just a second to explain what's going on in case it's not clear. So we do have one string player who's live. That's Dave Pello, who's actually the director of the ensemble, which is about to come in. And all the other strings that you hear are up here. These are 8 studio monitors. They sound incredible. And what they're playing are, well, I'll tell you more about how we did this after you listen to a little bit more. But the high, especially the high string violin section stuff that you hear is all coming from a computer. And the rest of the band is piano, drums, drums, bass, and saxes, trumpets, saxes, trombones, and trumpets. Okay, so this goes on for a long time. I'm going to jump to the end. So he's improvising, yeah. And boy, I hate to. So this is also a great tenor improviser in the middle, plays for a while. Yeah. So the strings are in the background. Okay, and I'm going to jump to the end, I think, if I can find this. Whoa, that was not, that was a little too much. Okay, so, yeah.
I find it hard to appreciate how much the system is doing without knowing kind of the rules of engagement on both sides. Like, who's doing the improvisation and who's sort of scripted music.
Yeah, so that's I want to tell you about that, and I'll tell you details about what the system is doing.
Yeah, building on the same question, like let's say the end of this piece where you saw, almost at the end of the solo where the strings come in and play. That
Yeah.
So is that part of the score, or is it is it waiting for some specific note for it to launch and then play? Or
well, so that's part. I mean, the point of showing you some different parts of this video were to illustrate some of the problems. That even though it's mostly steady tempo, there are things like at the very beginning, the strings were sort of following a bit of a rubato performance by the bass, and then at the very end, things kind of came to a hold, and then the conductor cued in the string section, which plays this very fast thing. So, yeah, so that's in the score, but the score says that there's going to be a little cadenza by the bass, and he's going to hold, and then they come in on tempo. So that's part of it.
There was one part at the very beginning that looked like an awesome thing. I don't know if it was really happening, but it was when the cellist was silent, and the exact moment that the cellist made his first sound, the strings came in. It looked like, within a sub-second at the same time. I didn't know how that was synchronized.
Yeah, well, so let's play the beginning again, so you can hear that. Yeah, like right there. Well, so he's actually conducting. So what's happening is so we're using in this case we're actually tapping in time, and I'll give you some more details. But there's no the sensing is not by audio. The sensing is from a much more kind of discrete foot tapping and manual cueing sort of thing, which makes the problem a lot simpler. We're using image capture, but it's through two human eyes that are watching the conductor, and the bass player is also watching the conductor. But even that, well, so let's get back to the. Oh yeah, good. I have a picture up here. So this is the implementation for that April concert. There's a foot pedal, and based on foot tapping, we're doing tempo estimation and sort of forward prediction of where the next beat is going to be. We also have a little keyboard which just provide some extra inputs that are used for cues. Because what happens, well, I'll talk about why we do this later. But anyway, the cues and the beat prediction are sort of integrated to find a score position, and the score position drives a variable rate playback of audio. And then what's happening for the variable rate playback, we have, again, 20 channels, 20 strings, each string on an independent audio channel, because that enables you to do very high quality time stretching. The time stretching works by labeling each period of each instrument. So we have something like 8 megabytes of just pitch labels. And so if you want to stretch a string out, let's say if you want to stretch by 10%, then you take every 10th cycle, every 10th vibration of the string and copy it. Copy that 10th one. So now you have 11 vibrations. And if you do the copying very carefully, you can do that with no glitches, and it's essentially artifact free. It works really well. And then similarly, if you want to play 10% in the other direction, I'm not sure which. If you're scaling the other direction, you can just leave out every 10th vibration, and then you play faster. No, one of the band members was.
Who was also playing another instrument at the time?
That was the original plan, and everything was built to do that. And it turned out that the arrangement did not call for vibraphones, and the band has a vibes player who's also an excellent percussionist, and she so she ended up doing the pedal so she'd have something to do. And
is this kind of like the system watching the conductor? Is that what the foot pedal is?
Yeah, and so she's listening to the band, she's watching the conductor. She insisted that she be able to have visual contact with the hi-hat on the drummer. So, the hi-hat's the little cymbal that it's called a sock cymbal that goes up and down, and this drummer for this piece would normally play that on the beat, so it was helpful to see that.
Doing semantic interpretation of a solo is about to end and things like that for cueing.
Yeah. So some of the cues are coming from the conductor. Some of it's just she can listen and she knows what's happening. But there were a number of string entrances, maybe 10 different entrances during the piece, and I intentionally made it so that they had to be cued. They would not happen automatically. And the main idea there was that if the band ever just really messed up and fell apart and got back together again, or if she messed up, then I or someone could kill the strings for that entrance, reset things and then bring it back up, and then they'd make the next cue. And in live performance, that people miss their cues. Usually it's not the whole string section at once that drops out, and that would be bad. But that's the audience would probably never know the difference. So that's what we always say when those things happen. Okay, so another interesting thing about the playback is there are a lot of systems that have been implemented to do this kind of time stretching. Usually it's time stretching by a fixed amount over some interval of time. And if you use Pro Tools or some other editor, you select something and say stretch this 10%. So what we're doing is actually doing the time stretching with interactive control in real time. And one of the things that happens there is that because the stretching works on periods of vibration, the amount of you can only cause time to jump ahead or lag by these discrete intervals. It's not really a continuous process. And so if you have 20 strings and they're all playing different pitches, and you're constantly kind of ramping them up and down in tempo to follow the band, then all these quantization errors are going to start piling up. and the whole orchestra would start, potentially would diverge. I mean, it's a kind of a statistical process. So what I had to implement was, so this SOLA is pitch synchronous overlap add. That's the process for reassembling this audio. Oops, sorry. And so we monitor. We have a buffer in front of the time stretching that is being filled from the 20 channels of audio into these 20 buffers. And by monitoring, whether the buffer is getting full or getting empty, we can modulate the amount of time stretching that we're telling the pitch synchronous overlap adds to do. So it's kind of a servo mechanism so that they all track each other and we don't accumulate any rounding error. So all that stuff's going on in real time during the performance. Yeah.
The audio input is an actual 20-piece string section performing that piece at reasonable tempos.
Yes.
Not generic samples, but somebody performing that.
Right. It's actual recordings. We did the recordings by first recording. It's a little. We actually did put down a click track, and then we had a rhythm section play with the click track so that they would be. It's actually the same rhythm section, so that they would give the kind of syncopated feel that the piece called for. And then we multi-tracked. We had 4 or 5 violin, viola, and cello players come in and multi-track the piece. So there were actually, we had at most 5 players, but we ended up with 20 tracks.
But they're recorded individually. Like you have recordings of each.
Yeah, each one on a separate. So we were able, with our studio, we were able to record 3 at a time in isolation booths. But it's all totally isolated. Okay, so that's an example. What I want to do is talk about the way I'm thinking about this problem. I see, what we did in April is just a first prototype implementation to learn about the problems, and now I'm really thinking about other ways to solve this, better ways to solve this, how to generalize this, and I think the way to think about this is to kind of analyze this type of performance, this popular music performance, and think about, just break it down into what are the elements, and once we have a more abstract way of looking at performance, we can think about how do we get the computer to do this. And so I have this thing I'm calling the performance model, which really has 2 parts. There's the listening part and there's the performance, the playing part. And so on the listening part, here's what you have to do to play music with other people. First of all, you have to know generally where you are in the music. So are we playing what piece are we playing? Are we playing letter A or letter B? Or is this the verse or the chorus? That type of thing. You also have to know the beat and the tempo, because again, we don't synchronize by synchronizing notes. We synchronize by having some abstract notion of where we are in the piece, and the primary structure there is really the beat, and the fact that the beat is steady allows musicians to achieve a lot of synchronization, even though they might all be improvising. So beat and tempo are really critical. The second thing is, and this wasn't obvious to me at first, but it's really important to know where 1 is. So what I mean by that is most music is in 4/4. I mean, other music is in 3 or 5 or 7, but generally, if you turn on the radio, you'll hear something in 4, which means the structure is 1, 2, 3, 4, 1, 2, 3, 4. So when musicians say, where's 1, they're talking about the downbeats of these measures. This other piece, da 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 da, 3, 4, da da, 3, 4. Those are all on 1. And so if you know where the purpose of finding 1 in music, again, something I never even thought about before thinking about this problem. The reason that we have measures and we think about where one is, and that's useful, is that beats go by really fast. You know, if we didn't have measures, it would be 1, 1, 1, 1, 1, 1, 1, 1. And if you're going at that rate and you try to nod to your musician, okay, let's come in now, you're going 1, 1, 1. You know, which one were you talking about? It goes by way too fast. I'll tell you another story. I just performed Sorcerer's Apprentice with a community orchestra last weekend. And that piece is actually written, so that's the bum bum ba 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 bum ba bum ba bum. This it's in 3. It goes 1 2 3 1 2 3 1 2 3 1 2 3. So this is 1 1 1 1 1 1 1 1 1. And so for the trumpet player, you look at the score and you play a little bit, and then you're out for 50, 60 measures on 1 1 1, and counting for dear life. And I finally had to. I mean, after the first rehearsal, I said, I just can't do this. I can't count 1 when 1 goes that fast. And so it turns out the piece really is structured into groups of 3 measures. And I think the notation is just wrong. But you know, who am I to tell Paul Dukas how to orchestrate? But I actually had to notate in my music groups of 3, and that enabled me cognitively to deal with the stuff going by. So 1 is really crucial, and that's if you're going to communicate and synchronize with other players, you do it on the basis of measures. So that's the point. And so you have to know where 1 is, and you also have to listen or sense what other players are telling you. So, you know, if the other player gives you a nod or the conductor gives you a downbeat or whatever, you know, somehow those cues are critical. And the reason cues are critical is that in this kind of music, people do improvise a lot. The vocalist might vamp for a couple of extra bars. Somebody might forget to come in. You might have a transition and the rhythm section forgets how many measures it is, and they add some extra measures. And so people do, in live performance, kind of look at each other, gesture to each other, yell at each other, whatever it takes to stay together. And so while all this perception stuff is going on, we're also performing music. So that means you have to have tempo regulation, phase regulation, which means just because I know where the beats are, that's not all there is to playing. If I'm a bass player, I might play a little bit ahead of the beat. If I'm a drummer, I might feel like I'm playing exactly on the beat. If I'm playing trumpet with this jazz band that I play with, it's really it's crucial that the horns actually play a little behind the beat. This is a big band, and it's just the style of the band is that we play behind the beat, and it makes it sound hip. It sounds cool. It's jazz, and sometimes guys will come and sit in with the band, and they're more classically trained guys, and they'll play right on the beat, and they're great musicians, and they play every note right, and they're on the beat, and we never invite them back because it just doesn't swing. So phase is really critical, and not very well understood and not very well studied, but so there's a whole set of problems there. And then there's dynamics, how loud you play, and expression, which is kind of everything else. So let's talk about some of these problems. The first one is know where you are in the music. So how do we do that? There's one technique for that I think shows a lot of promise is work on audio alignment. So I've done a lot of work in this area. Other people have too. This is an example. I pulled this from some classical music audio alignment. This is Beethoven's Fifth Symphony, first movement, and the horizontal axis is audio rendered from a MIDI file, and the vertical axis, I think, is the Philadelphia Orchestra, but it's a human orchestra playing, and using kind of a forced alignment, dynamic programming, and some features that are I can go into detail. It's called chromogram, but they're basically extracting spectral features. We can find the best alignment of these sequences of features that we extract, and actually match up two performances of the piece. This is a screenshot from Audacity that I'm doing some work on to integrate these algorithms so that we can feed in a MIDI file. This happens to be a Haydn symphony with a recording, and click Align, and the system will automatically match up the symbolic representation of the music with the audio. And so for doing live performance, the idea is knowing where you are. Is this a verse or a chorus? I think we can take existing recordings of the band, maybe made in a rehearsal, and quickly mark them up with, okay, this is section A, this is section B, or this is a verse and this is a chorus, and do some kind of real-time version of this matching. But there's a whole field of research here for following popular music performances in real time and giving feedback to musicians about where they are. So that's one issue I hope to work on. Knowing the tempo is the next problem, and so the first thought you might have is, well, we'll just use audio analysis and find the beats. And people that have worked in that area know that we've made a lot of advances, but it's still really hard. And if you want to do this reliably enough that you trust your computer to get up on stage with you and play and always know where the beat is, I find that pretty frightening. So that's why I've resorted so far to this foot pedal thing. I think that after doing this concert in April and actually looking at the hi-hat and seeing how consistent it was, I think there's a lot of room for combining multiple sensors, put even accelerometers on cymbals and drums, and use drum sensors, and use conventional beat tracking algorithms. And I think if we put all of that stuff together with a lot of sensor fusion sorts of technologies, maybe we can build something that's really, really reliable. And so that's a new direction to pursue.
How about following the director?
Conductor, yeah.
Specifically the video, like you can see that there's that movement.
Or even if he has some sensors in his hands.
Yeah, I've actually captured a lot of conducting gestures with accelerometer, wrist-worn accelerometers, and other people have used other kinds of sensors. And so far, the conclusion I'm reaching is that conductors, well, that might be an interesting source of data, but it's not enough, and it's not very reliable. In fact, I've also done interviews with conductors where they conducted, and we shot video, and then we asked them to review the video and tell us what were you doing, what were you thinking. And at least in the classical world, conductors will tell us, I'm not trying to indicate tempo or anything here, and I'm trying to fix this problem with the dynamics of the piano player, and then the conductor will say, okay, there, I got his attention, and we fixed that, and then I went back to, but. Yeah, it's very surprising. I think the common assumption is that the conductor is up there to tell everyone where one is and tell them what the beat is. And I think that's not at all what actually happens.
Also, anything you do to rely on a conductor is pushing you even farther back away from the popular music direction you're talking about moving into.
Yeah, that's right. Yeah, and so most popular music has no conductors. Yeah.
So kind of to follow the conductor as well as the non-conductor performances, I can imagine, and particularly in a data fusion world, watching the movements of the violin bows, all of them, or watching the moves of the hands of the guitar players, all of them, and being able to say, okay, I've got a pretty good idea, says the system, based on 35 sensors, or 350 sensors, or 1,000 sensors, that I know where we are, and I want to follow the guitar player now.
Yeah, and that's exactly the kind of approach that I think that we need, and So I'm very interested in pursuing that. Maybe not initially with 300 sensors, but yeah, I think that's exactly the right idea. That the beat kind of moves around among. I mean, where's the good place to find the beat is fluid, and so we need to not only have algorithms to look for the beat, but to try to figure out which data is reliable and which data is not. And so this is the whole fusion problem.
Dynamics and whatnot. There's lots of things.
Yeah. Okay, so foot tapping, sensors, there's a lot of room for machine learning in here. And let's go on to the next topic is where is one? And so in the music information retrieval world, finding downbeats has not been a real problem that people have identified. But I think there are some techniques, for example, finding out where are chord changes happening, looking at player gestures, and then what we did, the reliable, simple but kind of distracting way of giving cues is to just press a key or some kind of out of band signal, which for a percussionist is no problem, but you kind of have to have a free hand and you have to be thinking about it. The next thing is communicating cues with other players, and so the problem here is not how do you know where you are, but how do you know where you are. And musicians do this all the time in very subtle ways sometimes. So for example, when I'm playing with other trumpet players in a band, and we're typically playing different notes but the same rhythms. And so just standing next to someone who's breathing, inhaling, getting ready to play the note at the same time you are, you have this kind of sixth sense of that you must be doing the right thing because you're breathing at the same time they are. And it's something that you don't really think of consciously, except when they have an entrance that's one beat after you, and you breathe and they don't because they're doing the right thing. It's very easy. You either have to really trust yourself and go with it, or you can get faked out, or you just miss it in rehearsal, and then next time you make a note and remember that this is your solo and you don't have to synchronize with somebody else. But so those kinds of interactions, I think, are very hard to reproduce with computers, and so I'm not sure how to do that, but I think it's going to take some combination of visual displays. We talked about tactile displays, like put a something that would tap you or shock you or buzz you or something. And there have been some instances of people using, I guess, little vibrators attached to performers, so performers could signal each other, which I think is without making sound, which I think is a really interesting idea. But okay, so there's kind of a whole research area here of this kind of cueing during musical performances. And then we get to performing. Now that we've thought about listening and sensing, what about playing? And so part of this is tempo. And one of the problems is, given prior beat times, how do you know the current tempo and how do you estimate the time of the next beat? So initially I thought, well, we're dealing with steady tempo, so this is not really a problem. And it turns out that as I've been measuring tempo of live performances, I find a lot more variation than I expected. I mean, even a jazz ensemble playing with the drummer, keeping time will fluctuate tempo up and down 10% based on whether the soloist is getting excited or who knows what's going on. I don't really know, but I see the data and see tempo drifting a lot. And so this graph is an example of just saying, let's take n previous beats and do a linear regression and call that the tempo and use that to estimate where the next beat is. And then let's figure out for different sizes of n how good the prediction is. And so this is what this graph shows. So this says that if we don't use, if we only look at the two previous beats to guess the next one, our prediction error is kind of high because these are not true beats, but foot taps, and there's jitter and noise in the tapping. If we smooth over some more beats, like we go up to 5 to 10 beats, then we hit a minimum here where the prediction is pretty good. And then at some point, as n gets large, we're actually smoothing in data from a time when the tempo was different. And so we're using the wrong tempo to estimate the next beat. And as this number gets large, the error gets, well, this is up to 45 millisecond typical. Well, actually, I think this is the standard deviation. But anyway, we're getting large errors if the window gets too large. And of course, window size depends on the characteristics of the players and how steady things really are.
Yeah. So is this graph like kind of uniform across different genres, or is it something specific to particular?
Well, this general U shape I think is common, but the it would the minimum will move to the right as the music becomes more and more steady, and so it really depends on the players. Probably depends on the genre too.
The sweet spot seems to be 2 to 3 downbeats, right? I mean, if you get to the 2-beat thing, you're basically not even capturing, starting 2 measures.
Yeah,
So
yeah.
it seems like that would, sorry.
Yeah, so most, well, actually, yeah, so this curve looks like the minimum is at 6. There's some other data we looked at where that number got a little bit larger. But yeah, I think in the 5 to 10 range is typical. Yes?
Does your synthesis system have a delay in it? You have to sort of play early, initiate the play early?
Yeah, you do. And so that's why we can't really wait for a foot tap or anything. We want to predict it. And it also turns out that if you look at past data, again, with popular steady tempo music, if you look at past data, you can predict the time of the next beat more accurately than someone can actually tap on that beat. So when they're tapping, they're getting typically around 30 millisecond standard deviation around the true beat, which is unknown, but we have some interesting ways I could tell you about later for why do we know that it's 30 milliseconds when we don't really know where the beat is, but we do know that, and so using this data we can shrink that down to more like 20 or 25 milliseconds. Yeah.
In the piece you showed, there were a couple of string entrances from rubato sections. Did your vibraphone/foot pedal player learn to anticipate by audio lag, or did we just not notice? You know what I mean? If the vibraphone player signal to tap the pedal or press the key, maybe is the case there, right on cue, we would expect to hear some audio lag unless that person had kind of gotten good at it and was able to 25 milliseconds or whatever it is.
So what we did in this piece was the strings never come in immediately when the cue is given. So the cue is always given ahead of time. Sometimes that had to be done on
tempo in between beats in between the cue and when the string entrances.
Right.
Okay.
Right. And sometimes things were basically hardwired so that there wasn't actually a separate cue. It was just tapping, which was the scariest part, but it really wasn't such a problem because the tapping interface is so reliable. But for example, the conductor would go 1, 2, 1, 2, 3, 4, and so when the conductor did 1, 2, that enabled the tapper to get the tempo in her head, and then when he goes 1, 2, 3, 4, then she starts tapping, and I think she would only tap actually 2 beats there, and the strings would come in.
And that was in the small handful of constraints that you placed on the composer arranger, say that there shouldn't just be wild entrances that didn't have time for a safe count before them?
Yeah, he actually, we talked about all this, and he went off and did what he wanted. So I ended up, the only concession we really had to make is that between the slow section and the fast section, he wanted to just go something like 2, 3, 4, boom, and have the band come right in. And I said, no, you can't do that because the strings have to be there. So you got to give me two measures of count between the slow section and the fast section. So But otherwise, I mean, all this kind of pseudo-rubato stuff, we agreed that we weren't going to do that. And so, we ended up, it actually wasn't that much rubato. It's just the way it was written, it kind of sounds rubato.
I have one more question.
Yeah.
So on the previous slide, so when you were kind of adjusting, do you have some mechanism where you were like kind of like catching up if you were making a mistake, or I mean like calibrating the window size live based on some
No, and that's something we've tried looking at. So there's, for example, there's a formalism called a switching Kalman filter that tries to look at whether your model is fitting the data, and when it's not, you could switch to another model. We haven't had luck with these switching models yet, but I think that's possible. And I think that human players are doing something like that. That when the assumption is steady beat and somebody needs to change the tempo, it's very common in a performance with players that somebody does something. They go like, let's speed it up, or the band leader will say to the drummer, like, do something. And so that's kind of an out of band signal that's telling everybody, okay, reset your tempo estimation. And that seems to be necessary for humans. I'm not quite sure how to do that with machines, but it's a problem. Okay, let me just, I think I talked about this a little bit. Oh, yeah, and I want to get to, okay, so the point here is there are lots of interesting problems, and we could go through lots more of them. I want to just mention some other work with this example. I talked about this problem of professional, even virtuoso recordings are things that we have to, that amateurs have to contend with. Everyone hears them now. And so one thing I think we can do for amateurs especially, but very useful for professionals, is use computers to fix up their recordings according to scores or other information to make them sound better. So people do this by hand all the time, but it's extremely tedious. And so I've started looking at maybe we could automate a lot of this process. So this is a trumpet trio that I performed, and I intentionally played this without a click track. There were some long gaps where you had to just count and then come in and hope you were right, and I knew it would fail. And so this generated kind of what in the business we call a train wreck. So I'll play that, and then I'll play the editor output. Okay, so, and this is a picture of some of the waveforms. Like in the score, this note and this note and this note should actually all be aligned with one another, and they weren't. Okay, so I took the machine-readable version of the score, which could come from just a MIDI file, and the audio all as separate tracks, and I fed them into this little prototype editor that tries to look for timing discrepancies and fix them up. It also looks at intonation, and if something is generally sharp or flat, it fixes that. And it also looks at dynamics and tries to make everything balanced. And so here's the output. There's still definitely some problems, but and if I had realized what was going to happen in advance, I could have sort of made a different mode in this editor to handle this too. But I wanted to be able to claim that I ran this stuff through the editor, and this is what you get with no correction. And so here we go. So better intonation, better synchronization, better balance. I mean, it's really remarkable to think that you could just take that initial recording and in a totally automated process come up with this. So my my vision for amateurs and even professionals in the future is something like spelling correction, where you put the audio up on the screen and a little window pops up and says, "You came in early here. Do you want me to fix it?" And you say, "Yeah." And you just go through the score in minutes and make something that sounds like it was recorded by top studio players or something. Okay, so let me just wrap up and say that performers do two things. They gather information about location and tempo, where's one, they get cues from other players, and performers play music, and so there are problems of intonation and dynamics and synchronization, and each one of these is an interesting problem from a signal processing perspective, from a machine learning perspective, from computer science, and from music. And so and if we can do all of these things and put it together, then we'll have a system or kind of a whole new product category that just millions of people will find interesting uses for. And so that's, I've shown you a little bit of work that we've done to get started, lots of open questions for the future, and that's what I wanted to share with you. So thanks for your questions and attention. Yes?
When you introduced the problem of moving into the popular music domain, you hinted at the problems of score following for pop music, where there isn't really a score, so score following becomes a loose term, but like following the guitar, the sequence of guitar riffs and chords that are loosely interpreted. But then the work you actually did mostly, there was a score. There was a fairly rigid score where there might be improvisation injected, but there was a fairly rigid score. Have you actually moved down that direction toward following the loosely scored pop structure? You know what I mean? Following guitar chord changes and in sort of pop settings.
Yeah, well, so one thing I can tell you is this score alignment stuff that we've done. We've tried this on rock tunes, like Beatles tunes, for example, and what we found is that we would align MIDI files with actual Beatles recordings, audio, and very often the MIDI files are not really transcriptions of what they actually did. They would sort of be almost like a cover tune, but rendered in MIDI. And so in spite of that, we found that we could do alignment. So that would be cases where the vocal in the tune would be one melodic line, and somebody sort of did an arrangement for MIDI, and they harmonized it, and so they were actually injecting major melody notes on non-vocal instruments. There'd be more phrasing and improvisation in the audio vocal line than there would be in the notated score. And in spite of all that, we can't actually do alignment. Although when we do that, we're doing forced alignment, not sort of incremental score following. And so it still remains a question of, what's the latency going to be when you do the alignment? Yeah.
Yeah. Have you thought about ways you can have the computer give feedback back to the musicians? Because it seems like you're just looking one way with what you're doing, and I know there's some bands that will have like a drummer play with a click track live to get that integration. And it seems like if you could combine both directions, you might get some interesting results.
Yeah. Well, that's what this was sort of a little prototype, just imagining what an interface might look like. And so part of that is sort of the 1, 2, 3, 4 would blink on the display, so the computer could feedback where it thinks it is, and the computer could be updating measures. The idea is that as a musician, we know from some experiments that we've done and some evaluation of some interfaces that if you ask a musician to read a score and you put a display right next to it or something updating a lot of stuff, that pretty much the musicians can't think about both at the same time. And even if they know the music and they're just looking at the display, they'll look at maybe the 1, 2, 3, 4, and they'll never ever see the measure number, and so it's very hard in real time to think about music and keep track of multiple things. And so that's why I think it's such an interesting research problem. So you do the obvious stuff. And
That so that just those random cues that happen 2 or 3 times in a song.
Yeah. But I think what's actually going to happen is that you need some kind of display that maybe that doesn't work the first time, but which is something that musicians can learn to use. And if you present the right information and they know the information's there and they know how to access it, then when they're playing and they want that information, they'll be able to just glance at it. The same way that, if I'm in the orchestra and I've counted 30 measures, but I'm not quite sure if I'm right or not, I can turn to the guy next to me and go like this, and that means, are we at measure 32? And he'll either say yes he'll either do this back to me in some subtle way, or he'll say, or he'll realize that I'm wrong, and then we start talking to each other, because then it's clear that something is about to break down. And so, anyway,
okay.
Yeah.
You're in Pittsburgh, right?
Yes.
This probably is an odd question, but in Pittsburgh there is this famous MRI center where they do imaging of the brain.
Yeah.
Have you done any experiments where you have a musician playing or listening or reading music and seeing the brain images of the regions?
I have not. I know that there's been a lot of research on music performance and MRIs. It's just not an area where I've done any work.
It's natural because the MRI center in Pittsburgh is one of the better in the nation.
Yeah, and I know that they do a lot of real-time processing that I don't know if that's been picked up everywhere else yet, but I've thought about, it's one of those things where I think this is incredible. There ought to be some interesting, question I could ask and get a great answer to. It's almost like sometimes you see this a tool that's so incredible you want to find a problem to solve with it. But I haven't, I just haven't done that. Yeah.
I'm curious if you've thought at all about the maybe not quite so formal setting, but still a group setting. So like say you're jamming, but you're almost like performance jamming. So somewhere between the full open jazz thing and where you're still kind of coming up with pieces. So the notion is you still have parts that you might want to trigger and maybe loop, but you're coming up with them on the fly as you're doing them. So it's like you're kind of composing, you're kind of like building, as musicians will often get together, you're kind of like, yeah, that's a good group, but we want to build on it and stuff like that. I wonder if you've thought at all about like supporting that scenario and might help with that.
I think that's, so the question is about less structured performance situations and how, could computers support that. And I don't really have any good ideas there, although I've personally composed a number of pieces, not in this kind of popular music or steady tempo genre, but pieces for interactive computer and performer. So I see a tremendous potential there. I'm just not quite sure, how to tap into it. I think that it's going to be a really interesting opportunity if we solve some of these more standard problems. Then when you have information about where's one, what's the tempo, we have good communication and cueing mechanisms, then I think we might be able to drop in some computer music generation modules and ways of communicating with them. Yeah.
I wonder what you think about the video games like Guitar Hero and Rock Band, if they're good for getting people interested in performance and learning about music.
Yeah, I think Guitar Hero and Rock Band are incredible. They're, in 2000, I'm not sure how they're doing now, but in 2007 they outsold all music downloads. They were close. They're about $1 billion business each. But that's a serious music distribution channel. So one of the most interesting things about that is that there's a whole generation of young people interested in music now that are not only getting some performance experience, but they're learning about, let's say the Beatles or an early classic rock that a lot of us probably thought was just dead, and now there's, it's very popular because that's kind of the the genre, the collection of songs that ship with some of these products. So yeah, and I think that the feeling of interacting with other players and of mastering an instrument, even though I think mastering pushing on 4 buttons and watching that visual score has a lot of differences, but I think there's a lot in common, and I think that's why it's so popular. Is that I think it's natural to want to play music and to be involved in the production of music, and that really taps into that. So yeah, I think it's a great thing. I think at some point in the future, I think people are either going to figure out how to take advantage of these now millions of young people that have this bizarre music notation reading ability. They read 4 notes scrolling up the screen, but the virtuosity of good players is amazing. So it's clearly they've internalized a way of looking in advance and planning muscle movement and all this on this kind of real-time display. And that alone to me is fascinating. And so I can imagine future concerts where somehow the audience is really involved in producing music, and the performers will display scores using the notation of the masses, which is like Rock Band or Dance Revolution. Yeah.
You have talked about improving the performance of amateurs. So it's like correcting the pitch and correcting the tempo and all those things. Is it possible to make an amateur sound like a pro? I mean, you have some samples of a pro playing, and then an amateur records something and he wants to sound like the pro. I mean, just replacing as if the pro has played that part by that.
Yeah. So how can we make amateurs sound like pros, or have that sound? I think that's definitely in the realm of possibility and something to look for. Personally, I think that in a lot of cases, amateurs really have the ability to make the sounds they want, and they want their sounds to be in their recordings. And what's lacking is the consistency that I was talking to a conductor of the orchestra at Carnegie Mellon. They do some very adventuresome, very difficult pieces and perform regularly in Carnegie Hall in New York. And he told me that the real difference between a good college orchestra and a good professional orchestra is that a professional orchestra will rehearse they'll rehearse an entire concert in a few days and prepare it and perform it. And with a college orchestra, you would spend maybe a few months to do a really advanced performance. He says, so it takes longer, you have to work and you have to learn the parts, but the end result is the same. And sometimes the college orchestras play better than professionals, especially on very, very difficult pieces that you can't just really sight read and throw it together in a few hours rehearsal. You have to really break it down and work things out. And so that's just another side of this, is that it's the consistency and editing, taking all the good takes and putting them together might be more valuable than replacing with professional recorded samples. But I do think that's possible, and I do think that's a really interesting thing to pursue. Yeah.
Professional orchestras are really given only a few days to rehearse the piece.
Typically. Yeah.
How often do they change their music? Just
well,
days?
so in Pittsburgh, the Pittsburgh Orchestra plays every. During the season, they play a new concert every week, and every once in a while they have a week off. But they come in on Monday or Yeah, I think they get Monday off, and they come in Tuesday. So they basically have Tuesday, Wednesday, and Thursday to prepare, and then there's concerts Thursday, Friday, and Saturday, and Sunday matinee. So yeah, and I've been to rehearsals and seen when the Pittsburgh Symphony plays classical symphony like Mozart. It's common for the conductor to just play spots and say, okay, let's play the beginning. There might be some tricky section where you say, okay, everybody skip to this and we'll play this, but they won't even play the piece through once before the Thursday night opening. But these musicians are unbelievable musicians. You put anything in front of them and they play what's there. And of course they're practicing and preparing the stuff at home. So when they walk in on the first day, they've had the music for months, and it's their, they get paid big bucks to show up and know their stuff. So if anyone actually missed a note, so I'll tell you another story just came to mind. A Carnegie Mellon student, a horn player, subbed for the symphony, and I heard that in the performance, one of the other horn players missed a note, and the conductor, I'm not sure who it was, the conductor stopped the orchestra and looked at the student and said, you're not in college. And then he went on, and it wasn't even her that missed the note. Nobody said a word, but that's the level of musicianship that's expected, that nobody's going to miss a note, so all they have to really do is work on balance and articulation and expression, and the orchestra has to get a sense of how the conductor is going to conduct. But yeah, so it's a different, the professional world is a really different world. And it's even in Hollywood with film score reading, it's very much the same thing, only those guys usually don't have the parts in advance. They come in and they sight read, and they're expected to play everything down without missing a note. And I've talked to some of those players, even major motion picture theme from Rocky, that thing with all the trumpet players. One of my teachers played fourth trumpet on that. He said the thing in the movie was the fourth take, and nobody had seen the music before, that day when they recorded it. So, but they're phenomenal musicians, and they make a lot of money because they can come in and be perfect all the time. Yeah.
Yeah. So one question. So. Going along with the idea of knowing where you are and so on, you're doing beat detection as well as pitch recognition. So are you also coupling that knowledge with instrument recognition? Because let's say when you're playing quite often, there are certain sections, let's say in orchestral music where the violin is, let's say, accompanying one of the wind instruments and later on accompanying someone else. And in your example of your video, you had the whole string as almost like one single unit. Whereas quite often the strings are broken and the violas might be accompanying the bassoon or something else. Stuff like that. So are you also kind of coupling in instrument recognition to know where you are or to know that this is the right place to come?
We are not doing that. We're not coupling instrument recognition to anything else, not because it's not a good idea, it's just that no one knows how to do it. And so, one of the problems, I guess it's almost an unstated assumption in all of this music understanding work, is that we don't really know how to do source separation, and so everything we hear is kind of the composite of all the sounds at once, and we do what we can with that. Or we go out and we put separate microphones on each instrument and try to do source separation by we just try to keep it separate rather than merging it together. But I think that's there are some possibilities there, but so far people are getting better results and achieving more practical things by looking at pitch and trying to really strip out all the timbral differences. So whether it's a violin or a trumpet playing, the important thing is what pitches are they playing.
Probably have time for one more question.
Yeah.
Perhaps a silly question. The strings which are being played by the computer, those are pre-recorded sequences. It's not real-time generated stuff, right?
That's right.
Thanks.
So there's no improvisation there. All of their parts were notated and written out. And so essentially what we're doing is trying to cue them in and keep them synchronized.
Thank you.
Yeah, thank you.
Well, let's thank Roger again.
Yeah.